Hello everyone, welcome to my channel. This is tech.sam, and if you're coming across my channel for the first time, in tech.sam I talk about everything DevOps, everything cloud computing, and tech in general. So feel free to follow my channel, like my videos, and also share, and don't forget to turn on the notification bell so that you get notified whenever I drop any video. So 3 days ago, we started our 100 days of DevOps challenge. And so far in day one, we covered the introduction to DevOps and we're able to set up our environmental, everything we need. We set up our environment and all that we will need for this journey. For day two, we had introduction to Linux file system, and we were able to talk about some commands and how to basically navigate your Linux environment. So if you have not checked those videos, so please feel free to watch the first video, that's the day one video, and as well as the day two video. So today is day three, and today we are going to talk about something very interesting. We're going to talk about scripting. So one of the things that is very important, and as a DevOps engineer, one of the things you should be good at is scripting, is shell scripting, because that is like the foundation of automation. So that's basically one of the things that DevOps comes to solve, where it reduces manual input when you're trying to do things and try to automate things. And one of the ways to automate it is scripting. So under here, we're going to talk about, this section is divided into two. So today we'll cover the basics, why tomorrow we'll go into a little advanced scripting. So first off, we need to understand what shell scripting is. So before I talk about shell scripting, we first have to understand what exactly a shell is. So what is a shell? So a shell is like a program in your computer that processes all your commands. So it's responsible for the running around or the running of that particular computer. So when I type a command on my terminal and it gets processed, the shell is responsible for processing those commands. It's what enables the command that you type to actually work. So, and then we have different types of shells. So we have the born shell, we have the born again shell, we have the C shell, we have the corn shell, and we have the Z shell. So the difference in these types of shell depends on the operating system that you are using. So the most common shell type is the born again shell, which we call bash. So that's the most common type of shell that we interact with in your Ubuntu Linux, in your CentOS Linux, in your Red Hat Linux. So basically it's bash, but some other types of Linux flavor uses different type of shell, but the predominant shell that we use in Linux is bash, and that's why I'm going to be focusing on bash shell scripting for this particular section of our journey. So like I said, today is going to be the basics, and tomorrow we'll look into some advanced concept. We'll also be learning some commands that we'll use in our day-to-day activities as a DevOps engineer. So what is actually the need for scripting? Why do we do shell scripting? We need to understand that, and like I said, it's basically for automation. So it's basically for instead of doing some task repeatedly, so this abstracts the need for repetition when you are doing some things. Say for example, you are told to create if you're told to create one file, then that's fine. You can just go use the touch command like we did yesterday to create a file. But what if you're told to create hundreds of files? So you want to create 100 files. So how do you do that? You do touch and you do the touch command 100 times? No, that takes a lot of time. It's time consuming and it's actually stressful. So with scripting, you're able to automate some of these things that you are doing repeatedly. You're able to automate it. So that's basically the whole concept of scripting. So what we are going to learn is we are going to learn about the scripting basics. We'll cover variables, we'll cover conditionals, we'll cover loops, we'll cover arguments, functions, and then logging and writing to files. If you have a programming background, say you know Python or you know JavaScript and stuff, so this shouldn't be new to anybody who has a programming knowledge already, because it's basically like the same thing. In Python, we still have variables, conditionals, loops. All the concept is still the same thing, but how it is carried out is what differs according to programming language. So we don't call bash scripting a programming language. We just leave it as a scripting language, even though it some of the things looks similar to what you would do in your programming language as maybe a Python developer or a JavaScript developer. So without wasting so much time, let us go straight to our terminal and start doing stuffs. So just like I said yesterday, as a good DevOps engineer or system admin, so the first thing you want to do is to confirm that you are logged in as the person that you want to be logged in as. So we confirm, use who I am, then we confirm that this is Vetrax, then you confirm your present working directory. So you just to ensure that you are in the correct place. So you do that, and now we confirm that. So first off, we're going to look at different files have different extensions. So if I do ls, so I have a file here named renamed file.txt. This .txt is an extension. It tells the shell that okay, this is a txt file. So if you want to create a Python file, it will end with .py. It will end with .py. If you are creating a Terraform file, it ends with .tf. So these are extensions that shows or that tells the shell what exactly is this type of file. So that's what helps the shell to understand the type of program you're trying to run. So for bash scripting, the extension is .sh. So that's the extension for bash scripting. So if we're going to create a file, let's create a file script.sh. Oh, sorry, creating a file is touch script.sh. So we've created a file script.sh. So let's go into that file. Let's vim into the file. Okay, and let's press our I. So let's just type this is a script file, and let's save WQ exclamation. So let's save. So yes, what I also want to talk about now is for example, now there's no big deal about bash scripting. There's actually no big deal about it. Basically, it's just you arrange the commands that you're supposed to run on your terminal. That's your normal commands that you run on a terminal. Instead of doing the command repeatedly, or instead of doing like a whole bunch of things manually, you just put in those commands into a file and then you run the file. For example, you want to do echo. Echo is the command that prints out whatever you tell it to print out. So echo this is DevOps day 3. So if I press this, it echoes this is DevOps day 3. So it's this same command. If I should go into, so I'm going to do this same thing, but I'll put it in this script.sh. So let's vim into our script.sh. So I'm going to delete this. Now, before you start a script in bash, there's something you need to do. You need to tell the program what shell you currently want it to run on, or what shell you want the script to run on. So how do you do that? Something we call shebang slash bin slash bash. So this tells the shell that this is a bash script. This is a bash script. So this particular script can only work in a system whose shell is bash. So if I want this to work in a KSH shell, so I'll just do KSH. If I want a ZSH, so I will do that. So this tells you that bash script will not, if you have a script that is written in bash, it's probably not going to work in a system whose shell is a cron shell. So, but this is usually done so as to tell the shell or to tell the system what type of program you're running. This is the first thing that you do. You put your shebang slash bin slash bash. So whenever you want to write a shell script or a bash script, as this case may be, please do not forget to, this is very, very important. This is the first thing that you should always do whenever you want to write a bash script. So shebang slash bin slash bash. So you can change this depending on the type of shell that you want your program to run on. So we did what do we want to do? We want to echo this is DevOps day 3. So we want to echo, this was what we wrote on our terminal, which is, this is DevOps day 3. So we want to put it in a script. So we're going to save this. Okay, so we do ls. So now, how do you run a script? You run a script by, you just define where that script is. You define the part of that script. And on day 1, I think on day 1 or yesterday, I talked about relative path and absolute path. So if I do pwd, I'm in /home/vetrax, and the script is in /home/vetrax. So now, because the script is actually where I am, I can use a relative path and just do script dot sh. So I can just do slash dot and slash script dot sh. If it was in a different place, I have to define the absolute part of where that script is. For example, now if I do, I talked about this yesterday. If I do which ls, so this is where this particular script is. Now instead of doing ls, if I do /usr/bin/ls, if I click on it, it's still going to do the same thing. So this ls has actually been added to the part in this system. That's why you can just use just use ls and it works. So it's going to run, either you use ls or you use this particular place. So this one is the absolute part of where the script of that ls is. So that said, if I do script dot sh, press enter, it gives me permission denied. Why is it giving me that? It's not because I'm not a super user. I want to show something. If I do ls-l, so you can see that script.sh, there is no execute permission for it. And yesterday I talked about different permissions: read, write, and execute. So there is no execute permission for this particular script, and this is a script that needs to be executed. So yes, it has a read permission. That means I can read what is there. If I do cat script.sh, I can read what is there. Now, I can write into it, as I can edit what is inside this place. But can I execute it? I can't execute it, even though I'm the one that created this file. You can see that the user or the owner does not have an execute permission. Neither does the group or others have execute permission. So what do we need to do? We need to give this script the permission to be executed. So how do we do that? We do chmod, just like we did yesterday. Chmod. If we want only the user to be able to execute this script, I will do u plus x, and I will do script.sh. But for this, let me just use all. Let me give everybody execution permission. So when I click enter and I do ls-l, so you can see that the color has changed from white to green. And we saw this yesterday, that once you change the permission of a file, the color changes. That's according to the way this SSH client has been designed. But in this particular case, it's not just only particular to this SSH client. In your Linux as a whole, once you change the permission of a file, the color changes, just to indicate that this is not your usual file, this is not your regular file. And if you check over here, you can see that everybody has execution permission. So now let's go and retry the script if it's going to work. Echo, sorry, script.sh. So when I click enter, what does it do? It echoes, this is DevOps day 3. Now if you notice, this is actually there. Even though this is here, it is not printed out, and that's because this is a message to the shell in general, not just to confirm what type of shell you're running this particular script on. So this will not get printed out. It is only this command that gets printed out. So you might look at it that this is more stressful than trying to write your normal echo. I can just always go echo and just write it. Yes, you can ignore this if you're doing just one thing. But let's say you want to do 5 things at the same time. Okay, now let's create 5 files. Let's do touch file1.txt. So you press, if you want to do 5 files, you do touch file1.txt, can do file2.txt, file3.txt, file4.txt, file5.txt, and I do ls. So now I have file 1, file 2, file 3, file 4, file 5.txt. Now, it took me quite a number of seconds for me to create these 5 files. Now imagine that you want to create hundreds of files. So will you start doing touch file 1, touch file 2, touch file 3? No, that is where scripting comes into play. So let's remove everything that ends with .txt. No, remove everything that begins with file with letter F. What did I do now? I used this asterisk. Asterisk is a wild card that you can use. How do I explain this now? So the way you use it, the way you do it is you give it a criteria. Let's say, for example, now I did ROM, F, and asterisk. So what does that mean? It means that I should remove everything that starts with the letter F. So if the letter F is before the asterisk, it means the letter F is the starting point. So you remove everything that starts with letter F. If I do remove if I remove do star dot, or let's say remove T. So this means that the asterisk is before T. What does it mean? It means remove everything that ends with letter T. So this is just how it works. if the letter is before the asterisk, it means that everything that starts with that letter. And if the asterisk is before the letter, it means that remove everything that ends with. So these are just wildcards that you use to quickly get things done as a system administrator or as a DevOps engineer, as the case may be. So now let's vim into our script and let's do so we have echo. Let's do this. We want to echo. I want a space. So I do echo. Creating 5 files. Then we do echo. So when you do echo and you just do this, you are just saying like leave a space so that everything doesn't get muddled up. It's just good for readability. So this echo and empty asterisk that I'm putting is just for you to leave a space. So what's the command to create the 5 files? Touch file1.txt, file2.txt, file3.txt, file4.txt, file5.txt, echo files created. Kindly run the ls command. So let's save this. So let me clear my screen. So let's run our script again. So said this is DevOps day 3, creating 5 files. Files created. Kindly run the ls command. So if we run the ls command, you can see that we have our file1 to file5.txt. All right, so there's the command I want to show you. So this command is date. What the date command does is that it prints out the date of your current date. So we're going to write a script that will print out the current date, a script that will tell you who you are, a script that will tell you your present working directory. So let's vim into script.sh and let's delete all of this. So now, how do you print a command in a shell in a script? So I can't just come here and write date. No, the way to print a command is you need to put a $sign in front and then put it in asterisk and you write date. So if you notice the color has changed. So when you see this color, if you're using your mobile XTEM, so when you see this color, you'd and the color differs according to whatever you're using. So it shows you that you're writing a command. So let's confirm this. So let's do WQ. So let me run this script and see. Command not found. Sorry, I was made a mistake. Echo echo date. So let's see. Okay, so it's printed out the date. I needed to put echo there because we need to tell the shell what to actually do with that command. So I want the shell to echo that command. So we can then start adding to it. So we'll do echo today's date is. So close. Then we do echo, and we leave a space. We give a space, and we echo my username. My username is. What's the command for username? Who am I? So do who am I, and then echo and echo again. My present working directory is. The command for that is pwd. Command is pwd. So let's save. Let's try and run our script. So as you can see, it says today's date is this. My username is this. My present working directory is this. So this command can be used anytime you want, because now, for example, now if I cd into, let's say I cd into /etc. Now my present working directory is what is /etc. I'm going to run that command now. So you see that it's I didn't put the working directory when I was running the command, but as long as the command is there and you run that particular script, it's going to work like a normal command. So let's do /home/vertrax/script.sh. So when I click enter, you can see this is still the same because the date is still the same. My username is still the same. However, if you notice, the parent working directory has changed from what it was here. Here it was home/vertrax. Here it's /etc. That's because it shows you where you currently are. So this is just on a basic level. These are just things that you're supposed to know. So you can put as much in your leisure time. You can put as much commands as you want to put, and then you can even arrange them the way you want to arrange them. So another thing I want to quickly talk about is comments. So comments, it just helps readability. So it just helps readability. You can comments are not actually printed on the screen. Comment just shows anybody that takes hold of this particular code, or anybody that takes hold of this particular script, to know what exactly you are doing. It's not for the system, it's for the user. So, and it's not just in shell script, it cuts across every programming language. So to put a comment, you just put this hash symbol. Once you put a hash symbol, anything that you type after that hash symbol is treated as a comment. So I can say this is a script that checks that prints the current date, user, and working directory. So if you see that it has a different color, this just shows you that it's a comment. So if I should go ahead and run this program, if I should go ahead and run it, it's back to home.vetrax. It shows me my username, it shows me the date, but it doesn't show the comment. So that's why I said the comment. But if I do cat script.sh, so you will see that the comment is there. So this comment is not meant for the computer to show. It's not meant to be displayed. It's meant for like you and me that want to interact with this particular script. For example, now if I give this to somebody who isn't familiar with all this command or all this, is not familiar with what this particular script does, when he opens it up and sees this is the script that prints the current date, user, and working directly, it gives him or her an understanding that, okay, this is what this particular script is doing. So that is just an introduction of the things that you can do with shell scripting. So let's see what we have next on the list. What we have on the list is variables. So variables, how do I explain variables? Variables are instead of having variables are things that can change, things that can change in your script. So if you have something that can change in your script, you make it a variable. So instead of going to different part of your script, let's say for example now you have a very large script or large code as the case may be, and you don't want to repeat some things, you want to make one change somewhere and you want it to take effect everywhere. Let's say for example now you have you want to change the name. Let's say you have the name that keeps reoccurring. Let's say you have let's say Samuel. Now Samuel occurs like 50 times in the script, and when you go to your boss says no, he doesn't want it to be spelled as Samuel, he wants it to be spelled as Sam, just Sam. So what do? Do you now go back to your script and start making changes 50 times? It's going to be exhausting, and the goal we are trying to achieve here is minimal work. So that's where variables come in play. If you make Samuel, the name Samuel, a variable, what you do in that case is that just go to the variable. Once you change the name from Samuel to Sam, every place that variable is mentioned, it automatically changes from Samuel to Sam. I don't know if you get my analogy. So it just helps you to things that you know that occurs frequently in a script but can be changed at any point. It's better if you make them a variable. So let's see how to define variable in our script. So we vim this, and how do you define a variable? Let me delete this, or let me just comment. Let me comment all of this. So how do you define a variable? You can define a variable by giving the variable the name. So I want to give this is what the variable will be called in your script or in your code as you're writing. The variable will be called name. Then what are you assigning? What parameter are you assigning to the variable called name? So you can say Samuel. So now anywhere the variable name is called in your script, it is automatically changed to Samuel. So let's see. Let's try this. Echo hello. So just like we did for the date, for you to be able to call a variable, for you to pass in a variable, you need to have the $ in front. So you can do $. Some people do $ and just put the name of the variable. Some people do $ and put and do this and pass in the name of the variable. So whichever one you want to do. it's fine. But I prefer this because it gives me the impression that this is actually like a variable. It looks more variable-ish to me than just having just the dollar and the name, because I can just omit it. I might not really see it because sometimes I just see it as a normal name. But when I have this, it just gives me the you know instinct that this is actually a variable. So I can do hello Sam, and I close it and I save. So now what I typed is hello and the name of this variable. But when we print it, we'll see what is going to happen. So let's run our script. So you can see hello Samuel. But what we typed was hello and dollar sign and name. So for example, now I want to change this. I don't want it to print Samuel again. I want a different name. I can always go here, and instead of me coming to start changing from this place, I'll just come here and just say hello Elizabeth. So I'll just change it to Elizabeth, and when I run this script, it changes to hello Elizabeth. So that's why they call it variables. It can vary from time to time. So if you know that there's a particular will I say name or anything that is in your script that can change from time to time, and you're using them a whole lot of time, it's best if you keep them as a variable, so that when you want to make any changes to that particular name, you don't start going to your script and then before you know, if you want to make changes to everything, you might omit one, and that might cause an issue, and there might even be financial implications for just that mistake, that omission that you did. But once you have it as a variable, you just go, and variables are usually defined at the top of the script. So your variable should always be at the top. It just helps you. You can put your variable anywhere, but your variable for organization, your variable should always be at the top of your script, so that you don't start going up and down and start looking for where you kept this particular variable. No, everything should be defined at the top. For best practice, it should always be at the top of your script. So after that, this is just an overview of what variable is about. So let's move to conditionals. Conditionals are just like the name states. Conditionals are things that a condition has to be met before something can happen. So a condition has to be met before something can happen. So under these conditionals, we'll be looking at the if statement, the else statement, the elif statement. So we are going to go straight to our terminal now and start doing one or two things. So let's clear. Let's zoom into our script. I want to comment this out. Let me comment this out, and as well as this. So we are going to do if, we are going to do else, we are going to look at elif. So those are what usually called or tagged as conditional statement. So like I said, if you're from a programming background, this is actually not going to be new to you. So it's the same concept, just the syntax might be different. So let's do something echo. I want echo. So we're going to create a quick program now. So let's enter a number. There's a command called read. There's a command called read. Read is just like it receives input So this program now is going to be an interactive. The program we're about to write now is an interactive program where it's going to ask you echo a number. Let me make this okay, let me just say echo a number, and it just reads. If you type whatever number you type, it reads it and stores it into a variable named number. So it reads whatever you type and stores it into a variable called number. So I can name this variable anything. I can name read input. So it just depends on how you choose to what you choose to do with this variable name. So let's leave it as read input. So I've asked the user to enter a number. I have taken the number and I've kept it in a variable called input. So what then do I do with this number? I will now write a conditional statement. I want to say if the number is greater than so, it should echo number is greater than this. If the number is less than what the user typed, it should say the number is less than this. If the number is equal to, it should say the number is equal to this. So that's basically what the program is going to be about. So we're going to use an if statement. So this is the syntax where you write an if statement. If you put this, remember now, input is a variable. So if the user input, so how do we define variables? We do this and we do this and we type input. If input is greater than, so GT means greater than. There are so many arguments. GT is greater than, NE is not equal to, EQ is equal to, LT is less than. So I'm just going to write all this. I'm going to write all these things as a comment now. So if the number that the user typed is greater than 10, what should happen? You put a semicolon. Then if it's greater than 10, then what should happen? Echo number is okay, no, echo, I want that number to be printed out, so input is greater than 10. So I close this. The other part of, if it is not greater than 10, you should just say else. Else echo input is less than 10. And once you write your conditional statement, you end it with fi. Okay, let's modify this. I'm seeing an error because of the colors are not the way I'm expecting it to be. Echo is supposed to be in this color. Echo is supposed to be in this color. Then it's supposed to be in this yellow color, and it's not. And I've been trying to see what is the issue. So this is where the issue is. So let me just change this. Input is greater than 10. Input is less than 10. So that's the importance of having all these colors. So these colors, it shows you if something is wrong or if something is right. So I noticed that the colors were not what I expected. So I needed to just look, okay, what is the issue? So a single comma can actually affect your script or affect your code. So that's why you have to be very, very careful. And that's where these colors come in handy. Because if something is wrong, you will just know that something is wrong because the colors will be different. And at first you might not know, but by the time you interact with the terminal a lot of times, you will know which color you're expecting for which particular thing. So that said, let's run this program. Let me clear my screen. So like I said, so it's saying enter a number. Like I said, this script is an interactive script. It's a program. So let's pick number 50. So input is greater than 10. So let's run it and pick a lesser number. You say enter a number. Let's say 5. Input is less than 10. So that's basically a summary of how if and else statement works. Now, if I want to create another option where I want to be able to, okay, let me show this. Let me run this script and type 10, because 10 is our benchmark, is our yardstick, is what we are using to determine if a number is greater than or less than. So let's enter the number 10 and see what it brings out. So it's saying input is less than 10. However, 10 is not less than 10. So this is an error and we need to fix it. So how then do we fix it? That's where we have an elif statement. So we'll say if this is greater than 10, then we'll write number is greater than 10. So before this else, we'll just introduce an elif statement. You can say else if, so it's like another if statement, but instead of saying it's in between if and else, so that's why it's called an elif. So elif statement, so would write this if the input $, so if the input is equal to 10, don't forget your semicolon, then you should echo number is exactly 10, close that, then else we'll do input is less than 10. So what does this do? Oh, it shouldn't be eg, it should be eq. So this says if we ask for a number, we receive that number, we stored it in a variable named input. Now we're saying if this input, if this number that is in this variable is greater than 10, echo input is greater than 10. If this number is equal to 10, that's, we are trying to address the issue that we had previously when we typed 10 and it was telling us number is less than 10. So we'll say number is exactly 10. And if this input is else, that means obviously if we have tackled greater than and we have tackled equal to, the only thing left is less than. So we don't really have to define, we don't really have to write this block of script or block of code again when you're using an else statement. So else just does the opposite of what you've defined in your if and in your elif statement. So that's basically what it does. So let's try this out and see what we have. So clear, we'll run the script. So he asks for a number. Let's do 50 again like we did the other time. So input is greater than 10. So we'll run the script again. It asks for a number. Let's do 7. Press enter. Input is less than 10. So let's try it again for the last time. This time we'll write 10, which is exactly supposed to be equal to. So when you click on enter, you can see number is exactly 10, unlike the issue that we had before. So I'm going to give how do you know what command to write when it's greater than or when it's equal to? So I'm just going to vim my script again, and I'm going to put some comments. So when you have EQ, it means that it's equal. EQ means equal. NE means not equal. GT, which we used, means greater than. LT means less than. GE means greater than or equal to. And lastly, LE means less than or equal to. So there are so many other ones. These are just the basic. So you can also do more research and get the others. There's dash Z, there's dash F. When we talk about files, dash F for files, dash Z when a file is empty. So those are the other things that you can use for conditional statements. So yeah, so I'm just going to comment all of this. Leave them as a comment. So that they don't interrupt our program. So, and then I'm going to save this. So that's that about conditional statements. We looked at the if, we looked at else, we looked at elif. So the next we're going to do is loop. Loops are something that it's when you loop over something, that means you do things continuously. Like it's a continuous program until a certain criteria is fulfilled. It's just like saying do this continuously until this criteria that I've given you has been fulfilled. So when you hear loops, it has to do with continuity. That's what should actually come to your mind. And when we're talking about loops, we're going to talk about, there are different types of loops, but for this particular, for now, all we need to know which is the common ones is the for loop and the while loop. So basically, they do different things in a way that this can be used to create things. Both can be used to create things, but for for loop, you just explicitly you're giving it a task to do. You're giving it a task to do. That's for for loop, and you tell it to do this task for this particular number of times. So yes, do this task for this particular number of times. While for the while loop, you're stating a condition beforehand. So as long as that condition has not been met, keep doing this. Or as long as or until that condition is met, keep going over and over and over. So if that condition is, this is a very a loop that you take with care, because if you miss it, it can crash your system. So as long as that criteria has not been fulfilled, as long as that condition which you stated has not been fulfilled, it will keep going over and over and over, and it will not stop. So if you create a wrong condition and you run it with a while loop and the condition is never met, it can keep running until your system crashes. So you have to be careful while using the while loop. So the most common loop we use is the for loop. So let's go to our terminal and do one or two things. Okay, let's create a new script called loops dot sh. So let's not forget our shebang /bin /bash. Let's add a comment. This script teaches how to use for loops and while loops. Okay, so let's start with for loop. So it's just used to iterate over a thing. So let's say for, this is syntax for, then you give it a criteria. You can say for I in, this is like a variable. For that I is variable. So for I in 1, 2, 3, 4, 5, do, what do I want to do? I want to echo this is loop number dollar I, and I end it with done. So what this does is that it just counts. So I've given it 5 numbers. So what does it do is that when it goes, it creates, there's this I here is a variable already. So what it does is that this program checks these 5 numbers. So for each number that it checks, it echoes this is number, and that particular, that should be I, not 1 I. So this is number. So this particular I, for every time it goes through this number, like I said, variable assumes, like variable changes, something that changes. So when this program reaches number 1, this I is assumed to be number 1. When the program runs, it goes back and then picks number 2. So this I changes to number 2, and it goes like that till it gets to number 5. So when it gets to number 5, the program will quit, or the program will stop. So let's try it. Let's save, and we need to change the permission. Chmod a plus x loops.sh, we do our ls. Okay, so let's run our script. Okay, now we run into an error, echo an error in line 9. So this is loop number. So there's an issue with the syntax. So let's just go and it's not a problem. Let's go and fix it. Okay, now I see where the issue is. This is supposed to be a semicolon, not a colon. So let's try this now and see if it's going to work. Good. So this is loop number 1, this is loop number 2, this is loop number 3, this is loop number 4, this is loop number 5. So that's how to loop over, that's how to use the for loop rather. So that's basically the context of for loop. For dash in dash do this. So that's basically how it works. For dash in dash do this, and the whatever you define here is a variable. So if I change this now, to for numbers, let me say for numbers, for number in this, and I come here and do number. Now this number is now a variable. So if I don't define it here, my program will crash. So let me do, you see that to give us the same thing. So you can see this is loop number 1, loop number 2, loop number 3, 4, and 5. So you can give it any variable. So that's basically an overview about for loop. So let's go to the while loop. So like I said, In while loop, you first of all give a condition, and then you write your statement. So let me comment this out also. So let's do this. So I want to write a program that counts, that would continuously count. So let's define a variable. Like I said, you first have to give your condition. So let's say count is 1. So this program starts counting from number 1. We've defined that count is 1. Then we write our script. While count, that's the variable that we have defined, is less than 3, is less or equal to 3. What do we want to do? Don't forget the semicolon also. We want to echo count is this. So now we are starting our count from number 1. So while count is less than 3, we want to keep echoing that particular count. So let's write it down and let's see what comes out of this. So let's run our script. So you can see count is 1, count is 1, count is 1. So I'm just going to quit this. So I did this deliberately, so I was going to show something. And that's why you don't just use while loop anyhow. If you're not really good with it, or if you don't know what you really want to do, it's better you get more clarifications, and you can use AI's assistance, describe what you want and get the correct loop. So now what happened? We defined count as 1. We said as long as count is less than 3, echo count is this. Now, what did we tell it to do? 1 is less than 3. It will keep echoing. It will keep echoing 1 till, because it's meeting that criteria. We've defined our count to be 1, and count is always less than 3. So as long as 1 is always less than 3, it will keep echoing count is 1, count is 1, count is 1. What do we want to do? We want it to echo 1, echo 2, then echo 3, and exit the program. So how do we do that? We need to, you just need a little bit of programming knowledge to do this. So you can, by your leisure time, do this, and just get more familiar with it. I'm sure by the time you interact with it, by the time you get help from external sources, and you integrate AI also, you'll be able to do a lot of these things faster. So we want to increase the count. So that's one way to go about it. So now we're starting from 1. We want to tell it that after you have echoed the count is 1, increase that count by 1. So what we do is that we can just put this, we can say count plus plus. So if you do count plus plus, it means that we are increasing the count, number of count, by 1. So that's basically what it means. So it's just saying 1 plus 1. So I can just say this is count, new count. We can say new count is equals to so let me not complicate things. Let's just leave it simple. So what we've basically done is count plus plus. It increases the count by 1. If we want to reduce the count, we'll instead of plus plus, it will be minus minus. So we'll do this and we'll run this now and we'll see a difference. So you can see count is 1, count is 2, count is 3, and it exited. So let me vim that back. Like I said, while loop will keep running until a certain condition is met. So now the condition is while the count is less than 3, keep echoing the count is whatever number. So what we did here with this is that by the time the program, when the count started from 1, so it echoed count is 1. After it echoed this, it went to, because program it will execute line by line. So after it did this, it went here, it increased this count. So now by the time it goes back, count is no longer 1, count is now 2, because we have increased the count by 1. So count moves from 1 to 2, and it runs and it checks, okay, 2 is still less than 3. Okay, no problem. I will echo count is 2. Then it increases the number of count again. So count is no longer 2 again, count is now 3. So it now checks, okay, 3 is less than or equal to 3. So it goes again and echoes 3. And then it increases the number now to 4. And then it comes back to check. Now 4 is greater than 3. So immediately it confirms that 4 is greater than 3. It exits the script. That's like a short explanation of what actually happened, or the program that I have just written now. So that's an overview of what that's just on a basic level. This is what condition and loops do. So let's move to the next. So I'm just doing this on a basic level. So you would need to by your own self, try out a lot of things, do a lot of practice on your own for you to get more familiar or more conversant with these things. So we are going to talk about arguments. So what are arguments? Arguments are like things that you add to your script. How best do I explain this now? Arguments are like parameters that you add to your script. Let's say, for example, now you don't put that parameter directly in your script, but you create an argument for it. You pass those arguments when you want to run your script that's on the terminal. So I'm going to show you now so it doesn't look confusing. So let's create a file called arguments. Let me say args.sh. So first we'll define shebang /bin/bash. So what are we doing? Script to show arguments. So let's do echo first argument is. You create a variable for it. Now, from all that we've been doing now, I've shown like 3 or 4 ways that we can create variables. So second argument is, I give it a variable as $2. $1 will always be treated as the first argument. $2 will always be treated as the second argument. So close and echo all arguments I'll give it $@ shows all the arguments that you've given the script. So this is just 3 basic echo statements, but using arguments. $1 is first argument, $2 second argument. If you have a third argument, you put $3 like that, $5, $10. But if you want to show all arguments, you have dollar and the @ to show all arguments. So let's do this. Now we need to give it the execute permission. Chmod a plus x args.sh. We do ls-l. Okay, see it here. Now let's run this args.sh. Let's press enter. If you notice, it's printed first argument is and it didn't bring anything. Second argument is and it didn't bring anything because we've defined variables that we imputed variables that we have not defined. So how do you do this now? So I call this out, and then after this, instead of running this, we'll write something. We'll write DevOps. So whatever this first thing that we wrote now, it will automatically pick whatever you write first as the first argument. So if I should enter this now, it's going to show something different. So you can see it shows the first argument. That's the first thing that you write after the name of the script. So it shows first name as the first argument is DevOps. Second argument, because we didn't write any other thing afterwards, we only wrote DevOps. So all arguments are DevOps, just only DevOps, because that's only what I wrote. So now let's say DevOps is great. So now this will be taken as the first argument. This will be taken as the second argument, and this is the third argument. But let's see if it's going to display this great. So if we run it, you can see the first argument is DevOps. The second argument is. But we didn't define the third argument. That's why it's not showing as a third argument. However, it's showing as under all arguments because everything written after this particular script, everything written after it is treated as an argument. Each word written after it is treated as an argument. So if I say DevOps is great for learning and tech, it's still going to pick DevOps and is. But in all arguments, it's going to show DevOps is great for learning and tech because this is 1, 2, 3, 4, 5, 6, 7. These are 7 arguments. It's going to show everything. So that's basically how arguments work. So you can use them in your program. If you have some script that is really dynamic and you don't want to put those variables hard coded, you don't want to hard code the variables inside your script, you can just create arguments for them and then pass those arguments whenever you want to run that script. So that's basically like the purpose of argument. So second to the last on our list is functions. Functions is something that in programming, a function is is a list of commands. So instead of doing commands that are repeated, instead of writing the commands that are repeated, you create a function for those commands. So when you create a function, you write the commands and then you call that function. So whenever you call the function, those commands that you have stated under that function is what is going to run. Those commands that you're going to that you create under those functions is going to run. So right now it might be so much for you, but if you just know the basics, if you just know how to pass in your variables, how to put in commands and everything, that should be fine. But these are intermediate level scripting that you should know, because when you have a whole bunch of scripts that you want to write, there might be need for you to create functions for them. If you're coming from a software development to a programming background, this is a piece of cake for you because you already know all these things and it's basically the same, just a little tweaking with the syntax. So I'm just going to quickly show you how functions work. So whichever part that you don't understand, you can feel free to reach out to me. You can drop a message on the comments. You can reach out to me on LinkedIn. My LinkedIn account or my LinkedIn URL is on my profile on my channel. You can also reach out to me on TikTok, or you can also send a mail. So all these my contact details are in the channel. So just go to the channel and pick any means of communication, and then you can reach out to me, and I'll be so happy to respond, and I'll be so happy to interact with you. So let's do vim functions.sh. So just as always, define your shebang /bin/bash. So script to create a function. So what is the syntax for function? So you create a function name. Let's give the name, let's say script to create a greet function. So let's give it a name as greet. Then you open and close parentheses, and then curly braces. Then you now write whatever you want to be into this inside this function. So let's just do something simple. Echo hi, and I would like to use an argument here. So let's give it let's use $1. That's the first argument. Welcome to bash scripting. And then you close this. So we have created a function named greet. And this is what it does. This function echoes hi, an argument, welcome to bash scripting. Now, how do we run this? We have to call that function. And how do we call the function? You put the function name. So you do greet. If I didn't create this argument, I can just do greet and just do this, and it will work. But because I've created an argument, once you create an argument in a function, you have to define that argument. The first thing you put in that argument is going to be what will be taken as the first argument. So I can just do greet Samuel. And let's close this, and let's run our function script. First of all, chmod. Let's give it execution permission. Okay. So you can see, hi Samuel, welcome to bash scripting. Hi Samuel, welcome to bash scripting. So we defined Samuel here, and this particular variable we defined automatically gets fixed into this place. So there are different ways to use functions. So depending on what you want to do. So that said, last we have is logging and writing to file. So this is quite simple. So it's just basically you redirecting the output of something into a file. So let's see. Let's vim. So it's going to I'm just going to give you something similar. So I think I remembered yesterday I did something like echo. I used echo to create a file. So basically that's what we are going to be doing. Echo this is a test file, and then we redirect the output into test.txt, right? So when I click on enter, I don't get anything printed out to me. Usually echo statement will print out whatever you write, but I don't get anything printed out to me. Why is that? Because the output that is supposed to be printed out to me, I've redirected it into a file named test.txt. When I do ls, I can see test.txt. So let's see what is the content of that file. So you can see this is a test file. So instead of this echo statement being printed out to me, it redirected it into, it redirected it into a file, and when I view that file, it gets printed out to me instead. So basically it's something similar to login and writing to files. So we can create a script. Let's vim login.sh, and we do our shebang /bin/bash, and we do login and writing to files. So just basically what we did, can say instead of doing echo, I'll just do cat /etc/ I want to get the last 10 groups that we have on the system. So tail, if I do tail /etc/group, this is the command to get the last 10 lines in this file. That's the last 10 groups that was created in this account. So now I don't want it to display. If I run it like this, let's run it. Let me give it ch mode a plus x login sh. So if I run it like this, so it displays the last 10 groups that have been created on this system. Now I don't want to view, because sometimes when you're trying to, basically this can be used for error logging. So when you run a command and you don't want the output of that command to be displayed on the screen, probably you are taking a log for maybe your Docker processes, or maybe a process that basically you're taking a log for maybe a process, and you don't want the log to be displayed on the terminal. You can just, instead of displaying that log, you can redirect the output of that particular command or that particular log to a file, and then you can now check the file and do whatever you want to do with it. So I'm going to go back. Now I'm going to redirect that output to I. So I do this. That's the redirection key. I can say output.txt. So what does this do? Now remember, I don't have any file named output.txt on my terminal or on my system, but now I'm redirecting to a file named output.txt. So what Linux does is that it will get the command, and then it will look for that file, and if it notices that that file does not exist, it will create the file and then take that output and put in that file. So that's another way of creating files. And if you notice, I was doing vim, and then I'll just give any file name. So vim can also be used to create a file. Those files don't have to exist. Once you do vim and you write the name of a file, it automatically creates the file. It opens up your text editor for you to write what you want to write. So now let's run our command. So if you notice now, after running this script, it didn't display anything. But let's check, was a file created? Let's see. Yes, output.txt. So let's see the content of that file. So as you can see, when you cut into that file, you can see that what is here is the same thing as what is here. Now I want to show something. Let me zoom into this. So let's say I don't want to get the last 10. I want the last 5. I want the last 5. So you know the command is -n and the number. So let's do this. Let's run it. Now you know we already have the last 10 in output.txt. Now I want to have the last 5 also in output.txt. So when we run it and I do ls, okay, I will do cat output.txt. So if you notice now, we had this in the file before. Now we're supposed to add 5, the remaining 5 to it. But what happened? It completely replaced what was here before. So now a single greater than sign, a single redirection sign will always replace the content of a file. So it's advisable to use double. So if you use double, double means append. So append whatever output to what is already there before. Single means you're completely replacing the content of that file. You're completely replacing the content of that file. But if you put double, double will append. Let's do this now. Let's say echo, this is the first line. And I do line.txt. When I cut line.txt, it shows this is the first line. Now, if I say echo, this is the second line, and I redirect it into line.txt, it will replace completely what was written there before. When I press enter and I cut line.txt, if you notice, this is the first line is no longer there. It was replaced with this is the second line. However, let's get this is the first line back. When I cut it, this is the first line is back. So now I want to add this is the second line to this particular file. What will I do? I'm going to, instead of a single greater than, I use 2 greater than. So this will append it to, like it will write it in the next line after this one. So when I click on enter and I do cat line.txt and I press enter, now you can see that both are there. This is the first line, this is the second line. So it's just that's what you need to know about redirecting output of a command to a file. So most times if you're not replacing what is supposed to be in that file, then it's better you use the append. So there are some times that you might need to replace what is there. So you can use the single greater than. But in a case where you're not replacing and you want to store the logs. So in a case where you want to store the logs, it's better for you to append instead of replacing. So that's that about the basics. I really hope that we've been able to learn one or two things. If there's a part that you don't really understand, you can go back to that particular part in the video. You can rewatch it. You can also do your own personal research, and I'm sure probably I have not covered maybe everything. So whatever I've also not covered, you can feel free to drop it in the comments. I can look into it and probably make a separate video regarding that. So today we've learned about shell scripting basic. We've learned about the types of shell. We've covered variables, conditional loops, argument functions, and logging. So tomorrow we're going to take some advanced shell scripting. Would look at some commands. This is particular to system administration, DevOps, what we do as DevOps engineers, as cloud engineers, as system administrator, some commands that we use, and a little advanced stuff that you use in your day-to-day activities and in your production environment. So that'll be all for me. Enjoy the rest of the day, and I'm going to see you tomorrow. Cheers.